Thank you very much for coming. We have our second talk by Asheesh Laroia. He has talked about different scraping tools at PyCon before, but today he's going to talk about a new tool he hasn't talked before. So please give Asheesh a warm welcome.
So, hi everyone. Sorry that there's a little bit of feedback. I guess I'll try to speak a little quieter. Okay, and sorry about the blurry VGA. I don't know what to do about that, but we'll just go from here. So this talk is called Scrapy. It gets the web, as you can see. And thanks for noticing that pun. So I'm going to give you a tiny history of my own history with scraping to give you some background. Is that unreadably tiny and blurry? Okay, great. So in 2001, I discovered Python. Basically, the next few years I spent trying to pull data out of places that didn't expect me to pull data out of it, some of which were websites, some of which were this awful PageMaker tagged text format that's not HTML, it's its own thing. By 2004, I thought scraping is so cool, I should use it as an introduction to programming. 5 years later, I wrote a tool to download bugs from 500 projects across open source. That's the Volunteer Opportunity Finder in OpenHatch. In 2011, I was working on a tool to grab metadata about videos called VidScraper. And I tried a few different ways to download data in parallel, because we ended up with a lot of videos we needed to pull down data from pretty quickly. And then in 2012, I discovered Scrapy. And this talk is about sort of the epiphanies that came to me when I started using it. But before I talk about how great Scrapy is, I want to talk about how easy scraping in Python really is. I gave a 3-hour tutorial last year, but it's really just all on this slide. So you download pages. It's a good tutorial. People seem to like it. It has a couple views on YouTube. But I hope that many people here have seen the DOM inspector in web browsers. It's super cool. You right-click, you do inspect element. Holy Jesus, it's the parse tree of the web page. You can right-click on an element. You can copy the XPath. You can then place that XPath that you've copied from the web browser right into Python. You don't need to interactively play with beautiful soup and find out where the elements are. Nope, 21st century, super cool. So scraping is really easy. I'm going to talk with you about how you can take a sort of scrapy approach to writing scraping code, and that'll improve the quality of the scraping code that you're writing. So the thing we'll talk about writing is a tool to scrape the PyCon website for a list of all the speakers. So let's say you want to invite all the speakers to some kind of marketing lunch. Here's what you'll do. You start by finding the web page in your browser. You just click around and be like, this is totally the page. You don't just want the ones for just the talks. You want the tutorial presenters too. And if we were doing it synchronously, we would use requests by Kenneth Wright, who might be in the room. Okay. And then you would use lxml.html to parse the page, which is very resilient to broken HTML, although there's ways you can trip it up, but that's another story. And then you just pass a CSS selector. CSS selectors are great, because the truth is web pages are actually designed nowadays as APIs between the people who make the HTML and the designers who make the CSS and tweak that CSS. So you can just pick up on the API that's basically published to the CSS by using it in your scraping. And the thing is that the code that I'm showing here works great for getting all the speakers, but what it doesn't do is get the talk titles. And like anyone who writes software knows, once you write some software, someone else is going to tell you what you need to do now on top of what you did. So at the point where you need to start changing this code, we can think in terms of, we now need to think also about how to store the data we're going to be extracting. So I'm just going to show you a totally fake store datum function, which is just this trivial pass function here. But you can imagine it might take an author and a presentation title and go and save it to your database in Django, or fax it to Japan, or whatever you need to do with the information you're pulling out. And if you have this store datum function, then you might just make a small change to your synchronous scraping code that we saw. And at the bottom, just for each span as you parse it out of the page, pass it into that synchronous function. But there's something not quite right about doing that. And it is that if your stored_atom function crashes for some reason, so let's say your stored_atom function doesn't work properly with Unicode data that's not also valid ASCII, now your extraction code doesn't finish, it doesn't get all the way to the end, because the exception gets raised here, and your program will terminate. So if you're writing complicated scraping code, this is a common source of programmer wasted time, where you have buggy extraction and buggy data saving, and you'd like to at least iron out all the bugs on one of them without having the bugs on both sides make fixing one be gated on fixing the other. So what you might do is refactor it a little bit using Scrapy's items class. So Scrapy has this very simple wrapper for dictionaries, which I'm demoing here. This is basically very similar to named tuple, and it's conceptually similar if you had an instance of that to this dictionary here. The nice thing, the only serious feature that scrapy.item.item has is that if you access the dictionary via a key that doesn't exist, it gives you this nice error. So at least when you write your extraction code, you will be able to get all the way to the end of your extraction. You'll know that you have no typos in your dictionary key names, which, if you're like me, you probably did. So we can just marginally refactor the scraping code we wrote before, and instead of calling stored_atom inside the part where we do the data extraction, we return a list of all the items that we found. And then you'd have to have a separate function that loops over the return value of getData and passes them one by one to stored_atom. Pretty simple. But the truth is that scraping is somewhat complicated and brittle and confusing, and if you were to look at the scrape results, you would see that at least one of the talk titles in this year's PyCon contains more than one author. So now you have not just a specification bug, but an actual bug in the code. And at this point, you're going to have to make some changes. So the more changes you have to make to your scraping code, the happier you'll be if you wrote it with Scrapy. So here's how you would write this in an asynchronous scrapified fashion. You would write a class that defines the spider, and you would move your data processing into a method called parse. But one thing you'll notice is that this code never tells the web, I want to go download this URL. It actually just stores that URL in a list, but there's no synchronous request.get or urllib.urlopen. You actually just tell Scrapy, get this URL, and when you're ready, call me back on this parse method. So then the way to run this is by the Scrapy command line, Scrapy run spider your spider.py. Scrapy run spider is great. When it runs, it'll give you all this superb debugging information that's like overflowing your screen and my screen. But if you don't want that, so this actually is pretty cool, and if your parse method has an exception that doesn't get handled, rather than crashing your entire program, Scrapy will simply say, oh, I hit an unhandled exception while processing this URL, but that's okay, I'll keep processing other URLs as well as I can. And you'll see that in the log. But if you don't want to see all this helpful information about how much work it did and how proud it is to have done all that work, you can just disable the logging and set it so that it only shows you messages that are error level. But there's this question about where the data goes. I've told you how it downloads, but we haven't put in data into our database yet. Scrapy generally thinks in terms of outputting, by default at least, it thinks in terms of outputting to a file, a JSON file. By default, it actually puts that data on standard out, which is somewhat weird. So you can configure it this way on the command line by passing a new setting, -s, feed URI equals myfile.out. And I know that's not the most Pythonic way to configure an output file, but it'll do for now. So that's how you do it, but I want to look a little bit at a diagram of how of this, just to visualize it a bit differently. So your spider gets some responses out from the internet. Those spiders go into your parse method. The parse method creates one or more item objects, and those get moved along this item pipeline and dropped into this JSON file via the feed exporter. And you can actually customize what happens in the item pipeline. So if you want to, for example, only export authors that have queues in their names, you could add a little method here in the middle, a process item function to the middle of the item pipeline that enables that behavior. The other common thing to do with Scrapy is to put your data storage methodology here inside the process item methods that you can provide to the item pipeline. So if you wanted to have your work saved into the Django database, you can grab it here. The thing I really like about Scrapy is that it is sort of dogmatic about how to structure your scraping code. You must comply with this diagram, basically. Admittedly, this diagram was written last night by Karen. It's not like written by the scraping maintainers, but it does visualize how it works. So you can't, it saves you from designing things poorly. And the way that it does that is that basically the author of Scrapy is smarter than I am. So I've been scraping websites for like, I don't know, 12 years or something, but it took me reading the Scrapy tutorial and actually trying it to see the light. So Scrapy seems super cool, but the fact that so many of you are in here either means you know it super well and are going to flame me in the questions, or you don't know it super well and want to know more. So I was actually looking into how widely downloaded Scrapy is on PyPI, and it's pretty popular. In the past 2 months, 9,000 downloads have happened. But then again, there's this other scraping-related package that I use called Mechanize, which in the past 2 months has had 20,000 downloads, and Kenneth Wright's in the past, his request package in the past 2 months has had even more. So Scrapy isn't really super duper popular, and I'm going to show you a bit about why. So Scrapy, even though I love it, Scrapy really wants you to make a project. And in the tutorial is like top to bottom, okay, great. We're going to make a whole lot of files. The first thing you're going to do, this is going to be just like Django. It's going to be amazing. You're going to run Scrapy start project tutorial. And boom, here's like 6 files. You don't know what they do. And according to me, you don't even need most of them. But Scrapy comes with super cool features that litter the documentation with like thrill to read, but also like, where's the thing that I want? So Scrapy has this great feature called Scrapy, which is a daemon that you can upload your project directories to zipped up, and it will run the spiders from those project directories for you and save items out of the pipeline. You can just keep uploading scraping projects to this daemon, and it'll happily keep scraping them for you. Kind of cool, kind of intense. Additionally, every time you run a Scrapy spider, it starts a local telnet console that's a backdoor command line interface over TCP to your running spider. Super cool. And you can take a look at the execution engine state. It'll tell you, I'm not idle. I've been running since 21 seconds ago. It is also a real Python shell, so you can like eject the CD-ROM drive and do other fun things from it. So when I told you to do run spider your spider.py, really you should actually disable that, please. This is the kind of awesome features that Scrapy is littered with. And there's also a super cool web service interface that's similarly amazing. So the other major difficulty with Scrapy is that it's somewhat complex to integrate with other code. In particular, it wants to take over your running Python process. You're supposed to just configure your scrapers and then pull the Scrapy lever and then never touch your process again, except maybe with telnetting in. So normally, if you're writing like a linear script, you want to like call request.get on a URL and then handle the response in your code. In this case, you sort of configure it and then go. So it is a bit difficult to integrate with. We'll talk a bit about how I think is the best way to integrate with it, despite all that. I have mentioned so far that Scrapy is async. And we're going to talk a little bit about what that means and what the benefits are. So in the original scraping demo, we just downloaded one page. And so Scrapy was told via the configuration, hey, start downloading this URL, and then it'll, by default, hand the results to the parse method. But we didn't see how to make a follow-on response. So for example, if you not only need to get the authors and titles of the presentations, but you also need to get the bios of the authors, then you need to go get the author page on the PyCon website. And if you're doing that, you need to make another request. So the general principle for what to do when you're making another request in Scrapy is that if you're not done, you say so. So if your parse function is just not quite ready yet, it doesn't have all the data it needs to create an item, it's fine. But don't hold up the rest of the world by doing some synchronous call. What you do is you say, OK, instead of just yielding an item, all the best I can do is say, the answer to this lies, as soon as you get me that other URL, I'll need the response back, and then I'll be able to create an item for you. So your function ends with yield request, basically. This is from scrapy.http.request imported. And So you do need to configure what method of yours will get the data, will get called when the data becomes ready. So the other thing is you might need to store data available between those requests, because if you're getting the bio on an author page, you basically have a 2/3 ready item, the speaker name, the presentation title, but you're just missing the bio of the author. So you would create that partially created item, pass it through in request.meta, and then your other handler can pick it back up and keep processing. So it does look a bit sideways, but it's super convenient. And one of the ways that makes it, one of the benefits you get from it is performance. So originally with the OpenHatch bug downloaders, I was crawling 500 projects bug trackers, and it would take 26 to 50 hours unless the Fedora bug tracker was being extremely slow, in which case it would never end and I would have to Control-C it. And it was in a daily cron job in the background, so now there's like 2 of them running, so now you have to write a wrapper script around it to have a log file. And then the early data is going to be 2 days late by the time the job even finishes. So that wasn't super great. I'm not going to go into the alternatives for doing parallel downloading right now, because there's not very much time at all. But I tried using multiprocessing. That lets you download things in parallel with synchronous downloading, but it means that every URL you want to download, you have to spin up an entire Python process only to have it wait on a URL from the internet. And in fact, that URL might never come if the remote search site is timing out. Now your exceptions are trapped in another Python process. Things get weird fast. Similarly, with gevent, things get weird fast. So alternatively, with Scrapy, we do 200 connections per second in real time in one Python process. Scrapy doesn't really care. It doesn't use up too much RAM, and it made the thing run 95% faster. So that was pretty nice. And all I had to do was change the way I was getting data so that I wasn't getting it, because Pablo's smarter than me. I just told his code, when you get that data, let me know. The other great benefit of using Scrapy is how it makes testing super easy. So how many of you have written scrapers in this room? OK, of you guys, how many have written tests for those scrapers? OK, pretty good. Like literally at least a half dozen. So if you are writing a scraper that uses the Scrapy API and it loops over some response and does some calculations that eventually yield some items, PyConPresso here being a Scrapy.item.item subclass, let me show you how to test that. You just create a response object as if it came back in off the internet and pass it right into the parse method. So this is the code to do that at the bottom of the page, the code on top, the test on bottom. You just create the response. You don't need the internet. You can do this all offline. And you just instantiate the spider, create a list of what you expect to get out of it, pass the response in, and you just test the behavior of your code. If it got that response, what would it do? Yes, it would return the items that you expected. The ability to do that with just snapshotting the HTML file with wget or something makes life so easy. So I'll gloss over this, but you'll notice that this really only handles the situation where there's one request that goes out to the wire. If you yield a bunch of items but also a bunch of requests, then you need to use my module called autoresponse, which just gets configured with URL to file name mappings, and then it creates the responses as needed. Yes, it creates the responses as needed in response to the request objects created by your parse method. So there's only a handful of minutes left. I want to zoom through a few wacky tricks you can do, since I've said I would talk about them in the abstract you guys all read. The first one, though, is that there is a setting for everything. You don't have to specify your user agent. You just configure it. You don't have to implement concurrency. You just tell Scrapy how much concurrency you want. You don't have to write your own automatic retry code. You just actually do nothing because it's there by default. So when the remote site is down, you just don't change your code. Scrapy just schedules your request to handle later, and it will handle it as many times as you've configured in retry times, which by default is 20. And you can have it do random retry. It's a treasure trove of just useful tricks. And the documentation actually for Scrapy end-to-end provides a really good tutorial on how to use the Firebug and Chrome inspectors to get XPath selectors from web pages. super quickly, there are a lot of JavaScript-y web pages out there. There are two reasonable ways that I've seen so far to deal with those, if from Python at least. The first is by just instantiating the Mozilla JavaScript library, So I used this in a demo in my tutorial where there was an old anti-WordPress comment spam thing that just like had a script tag, had some JavaScript code to run, and it was like, bots will never run this. So I'm like, OK, I'll just run it. I'll find the script tag, I'll grab the text content, I'll pass it into the SpiderMonkey runtime, and I'll evaluate the script. Great. And I noticed when I was checking my mail before this presentation that a year ago after that talk, someone else had successfully defeated my comment spam with the same mechanism using the same code that I had used in that tutorial. So good, people are watching. The other way at the bottom of the page is to use Selenium, which will automate an entire web browser, which is like super cool, right? So in the beginning of your Spider, you not only tell Scrapy, go prepare your sweet asynchronous HTTP response world, but also bring me a web browser, make me Firefox or Chromium or something, and whenever pages come in from Scrapy, you then go tell the browser, go download the page again yourself, and execute this XPath on it, and give me the results. So it's kind of a mess because you end up with the browser and Scrapy both downloading the same web page. But the nice thing is that the browser is the one doing the search inside your document. So whatever JavaScript happens is what it will give you back. There is a built-in integration method for Django. So we talked in the beginning about this item class, which lets you specify a list of key value pairs, basically, that define an object. And Scrapy has a built-in Django item that you can just import. It works kind of like Django model forms in that you specify a model to have it wrap, and it makes a Scrapy item corresponding to that. The way that the data would get saved into your database, if you use this Django item, is you add a process item method into your pipeline, so that when the responses come in, they go through your parse method. Before they get to the feed exporter, you save them to your Django database, and then you throw them away so they don't end up in your JSON file of the results. Alternatively, which is what we do at OpenHatch, we just let Scrapy generate a JSON file, and when it's finished an hour later, we just have a little Django management command to suck in the results, process them there, and then basically that means that for one thing, the downloading code can easily run in a separate server than the running code. You can just copy the results file. It also means that I think, makes this testing story very clear. There's a very sharp boundary. So to me, the best way to integrate with Scrapy is to always leave as much of your HTTP going out to the net as you can to Scrapy. Don't try to do it yourself. You'll end up with hilarious timeouts, and you'll end up in hilarious situations where your app doesn't respond to the user because some web service you rely on suddenly IP rate limited you, and now you're crashing all over the place. So yeah, don't do your HTTP yourself. If you're impatient, grab the data from the pipeline before it hits the feed exporter, and if you're patient, then just wait till it gets in the feed file, pull it out from there. I have mentioned that that Scrapy is async, but I only just said the word twisted now because I get to see my next slides. Some of you might have seen Garfield minus Garfield. Scrapy is like twisted minus twisted. So there is twisted under the core, but the documentation, I think, mentions it 0 times. And I haven't written a deferred. I haven't imported anything from twisted. I live this very simple, convenient life with Scrapy. I just think about HTTP responses and requests. So that's all I have for you. If there's one takeaway to take from this, it's that you should separate the code that generates HTTP requests and responds to them. Even if you're not using Scrapy, you should do that. But once you do that, you can then get all the benefits of Scrapy anyway. Thanks.
We're going to have 5 minutes for questions. So if you have a question, walk up to the microphone, then just right down here in the middle. Make sure the microphone gets you and you speak loud so that it could be in the video. So if anyone has any questions.
Hi. I can just repeat your question. Go ahead.
Does it have a particular article which is saying, I'm a scraper and I'm doing this?
The question is, when Scrapy does a request, does it send a header that indicates that it is Scrapy? And the only header that it sends tells it that it is Scrapy is the user agent header, which is configured by default to say Scrapy and then the version number. But that user agent header is also one that's part of the settings, and you can override it.
Yes. I was working through the tutorial problem and found there were some typos and things of that sort. Are there, other than the Scrapy main site, are there any other places for documentation?
You said that the Scrapy main tutorial has typos that you found, and you asked if there's other documentation. So there's a lot of random blog posts and Stack Overflow Q&A. There's also a Scrapy users mailing list where the author is very responsive.
Okay.
If there's typos in the documentation, we should fix those over the sprints. So email me or file a bug or something.
Absolutely. Thank you.
Do you have issues with service providers or sites considering Scrapy to be like denial of service or violation of terms of use agreement?
I've ever written that have gotten me kicked off of sites have been with Scrapy. Also, Scrapy is super good at avoiding that problem, actually, because I'm only partially answering your question. Because you can tell it to limit to one concurrent request per host and even have a long delay between hosts. But if you're downloading pages from like 200 hosts, like for the bug importer, then your downloading still happens super fast. It's just that the speed is spread across lots of sites on the internet. And you should always read the terms of service and decide if you want to be scraping that site.
Thank you.
Oh, but I guess I will say that even if you're doing things that don't feel at all like scraping, Scrapy is really good just as an asynchronous HTTP framework that you should use for dealing with APIs above the board.
Question about blocking. Is there anything that you could do that...
Microphone.
Can you hear me now?
Yeah, great.
Great. Are there any things that you happen to run across where you cause Scrapy to block, like you do long writes to a database or something? Do you kick those out to after the feed exporter, or,
So my strategy is to just keep my Scrapy use very pure, and therefore it just saves its data to the feed exporter as a JSON file. Actually, it's a JSON list, which is another marginal JSON lines format, but it's the same thing. So by doing that, I avoid thinking about
you
blocking.
avoid that completely? All right, great. Thanks.
We only have time for one last question. So
Okay.
your question.
Hi, very nice talk.
Thanks.
Just wanted to say I'm from Uruguay, South America, the place where Scrapy was developed. I'm a friend of Pablo Hoffman.
Oh, cool.
And
Is he here?
no.
Okay.
And they have a very nice tool called Scrapy Cloud, where you can deploy and monitor spiders. It's a very nice tool if
Yeah.
you want to try.
Cool. Yeah.
Okay, so thank you very much, Asheesh.
So in 2001, I discovered Python. Basically, the next few years I spent trying to pull data out of places that didn't expect me to pull data out of it, some of which were websites, some of which were this awful PageMaker tagged text format that's not HTML, it's its own thing. By 2004, I thought scraping is so cool, I should use it as an introduction to programming. 5 years later, I wrote a tool to download bugs from 500 projects across open source. That's the Volunteer Opportunity Finder in OpenHatch. In 2011, I was working on a tool to grab metadata about videos called VidScraper. And I tried a few different ways to download data in parallel, because we ended up with a lot of videos we needed to pull down data from pretty quickly. And then in 2012, I discovered Scrapy. And this talk is about sort of the epiphanies that came to me when I started using it. But before I talk about how great Scrapy is, I want to talk about how easy scraping in Python really is. The PyCon website for a list of all the speakers. So let's say you want to invite all the speakers to some kind of marketing lunch. Here's what you'll do. You start by finding the web page on in your browser, you just like click around and be like, this is totally the page. You don't just want the ones for just the talks, you want the tutorial presenters too. And if we were doing it synchronously, we would use requests by Kenneth Wright, who might be in the room. Okay. And then you would use lxml.html to parse the page, which is very resilient to broken HTML, although there's ways you can trip it up, but that's another story. And then you just pass a CSS selector. CSS selectors are great, because the truth is web pages are actually designed nowadays as APIs between the people who make the HTML and the designers who make the CSS and tweak that CSS. So you can just pick up on the API that's basically public. I gave a 3-hour tutorial last year, but it's really just all on this slide. So you download pages. It's a good tutorial. People seem to like it. It has a couple views on YouTube. But I hope that many people here have seen the DOM inspector in web browsers. It's super cool. You like right-click. You do inspect element. Holy Jesus, it's the parse tree of the web page. You can like right-click on an element. You can copy the XPath. You can then place that XPath that you've copied from the web browser right into Python. You don't need to like interactively play with Beautiful Soup and find out where the elements are. Nope, 21st century, super cool. So scraping is really easy. I'm going to talk with you about how you can take a sort of scrapey approach to writing scraping code, and that'll improve the quality of the scraping code that you're writing. So the thing we'll talk about writing is a tool to scrape to the CSS by using it in your scraping. And the thing is that the code that I'm showing here works great for getting all the speakers, but what it doesn't do is get the talk titles. And like anyone who writes software knows, once you write some software, someone else is going to tell you what you need to do now on top of what you did. So at the point where you need to start changing this code, we can think in terms of, we now need to think also about how to store the data we're going to be extracting. So I'm just going to show you a totally fake store datum function, which is just this trivial pass function here, but you can imagine it might take an author and a presentation title and go and save it to your database in Django, or fax it to Japan, or whatever you need to do with the information you're pulling out. And if you have this store datum function, then you might just make a small change to your synchronous.
Thank you very much for coming. We have our second talk by Asheesh Laroia. He has talked about different scraping tools at PyCon before, but today he's going to talk about a new tool he hasn't talked before. So please give Asheesh a warm welcome.
So hi, everyone. Sorry that there's a little bit of feedback. I guess I'll try to speak a little quieter. OK, and sorry about the blurry VGA. I don't know what to do about that, but we'll just go from here. So this talk is called Scrapy. It gets the web, as you can see. And thanks for noticing that pun. So I'm going to give you a tiny history of my own history with scraping to give you some background. Is that unreadably tiny and blurry? OK, great.